Okay, our next presenter is Michael Nguyen-Truong. He is a second-year PhD student in biomedical engineering, and he knew he wanted to study biomedical engineering after his professor presented a Daft Punk music video to showcase the concept of tissue regeneration in one of his undergraduate biomedical engineering classes. With his degree, he hopes to improve outcomes for patients suffering from heart failure. The title of his presentation is Preparing Stem Cells in Their Fight Against Heart Failure. What is their ideal niche?
A global pandemic known as heart failure affects 26 million people. That's a lot of hearts that don't love their owners back. Fortunately, a lot of research has gone towards understanding and treating heart failure. However, much of this research has mainly focused on the left heart, while its distinct partner in crime, the right heart, has been severely neglected. Over 1/3 of people diagnosed with right heart-related diseases will die within 3 years. With this in mind, I decided to study right heart failure. Using healthy and failing sheep hearts obtained through collaborations with our very own veterinary teaching hospital, I examined the mechanical and functional changes of the right heart under chronic disease progression. One of my findings was that the right heart remodels and stiffens as its condition worsens. Because of the similarities between sheep and human hearts, discoveries like these are pushing the boundaries of much needed clinical right heart failure research. However, the disease is only half of the story. The other half is the treatment. Another hallmark of right heart failure is the loss of blood vessels that leads to a reduction in blood flow, starving the heart cells of oxygen and nutrients. Stem cells, however, have this amazing ability to secrete proteins that will help regrow this blood vessel network, like fertilizer for plant roots. Despite this remarkable therapeutic property, their performance in a non-native environment, like a diseased heart, is still unclear, limiting their efficacy for cardiac repair. As a result, I will use my acquired sheep data to study how the right heart's biomechanical properties affect stem cell potential in restoring blood vessels. Firstly, I will culture stem cells on scaffolds, which are houses for cells, that mimic the healthy and diseased right heart. Then I will use an array of biochemical assays to assess differences in the production of key proteins between the two groups. With the support of faculty in the departments of mechanical engineering, design, biomedical sciences, and chemistry, this multidisciplinary and cross-college study will be used to fill in a critical knowledge gap in both stem cell mechanobiology and heart failure research. Ultimately, these findings will instruct precisely primed stem cell therapies for the many patients suffering from heart failure. Thank you.